Okay, so we're going to plot the points. So I have 3, 5, over 3, up 1, 2, 3, 4, 5. That's point A. I'm going to label mine. If you didn't, that's okay. -2, -1. That's B. -8, +1. C. 6, -4. 5, 0. And 0, -6. Okay, do y'all remember how to number the quadrants?
Yes.
It's a C. Do y'all remember that? Okay, so this is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. And I know that those are fancy new Roman numerals. I will write them as just numbers over here because Roman numerals throw off my brain. Okay. So what quadrant is point A in? 1. What about B?
3.
C? 2. D? 4. Okay, E, is it in a quadrant?
No.
Where is it?
On the line.
What line?
X.
On the x-axis. And what about F?
On the y-axis.
So if it's not in a quadrant because it's on the line, just tell me the line. Yes? Cool. And then when you fill this information into a table, you should always do X from least to greatest, right? X should be numerical. So what's my smallest X value? So we have -8 and 1. Then what?
-2 and
-2, -1. Then what?
0, -6.
Then we have 3, 5, 5, 0, and 6, -4. Okay. Does anybody remember what domain is?
Isn't that the X?
Yes, so it's all possible X values. And when you find domain, you go farthest left, you start left, and you work your way right. That's what keeps it least to greatest. So left to right. Range is the opposite. It's all possible Y values. A lot of times I call this your height to remind you that it's your up and down. Okay, and it's you start your lowest and you work your way up to highest, which will keep it in least to greatest form. Because domain and range should always be least to greatest, numerical order. So if I had to find the domain for this, well, what are all my possible X values? Didn't I list them in the table? And they're already in numerical order. So my X values are, we list them in fancy brackets. -8, -2, 0, 3, 5, 6. Now your range is not always in order. So what's your smallest Y value? Then what? -1, 0, 1, 5. And if they repeat, you don't have to write it more than once. So if there was like 3 and then 3 again, you would only write 3 one time, yes? Okay, a relation is just a set of ordered pairs, a set of points. Anybody remember what a function is?
Isn't that y over 60?
I mean, linears are functions, yes, but how do we know if something's a function? Does anybody remember? What cannot repeat?
The x.
The x cannot repeat. So a function is a relation where x does not repeat. Now, does it say anything about y? No. So can y repeat all the way across? Yes, as long as x does not repeat. Does that make sense? Y can repeat all day. X cannot. Okay, so we're going to jump into it. So the first thing we're going to do is find domain and range from ordered pairs. We like these. They're super simple because it's listed for us. Just a reminder, your ordered pairs are always x, comma, where'd my other color go? Y. So I'm going to go through and I'm always going to look at my x's first because I'm going to realize that's going to help me realize if it's a function or just a relation. So functions and relations, functions are always relations. Look at the definition, a relation. So a function is always a relation. But is a relation always a function? No. Okay, because it says a set of ordered pairs, and you'll see the difference in a minute. So I have -1, 2, 7, 8. Did x repeat? No. So this is a function and a relation. I only underlined the x's. Okay, and now I'm going to list them. Well, the nice thing is they were already in numerical order, -1, 2, 7, and then 8. Okay, now range is my y values. So I have 1, 3, 3, 6. Bless you. So what's my smallest y value? Then what? And then 3 repeated. Do I have to write it twice? No. What's my next value? 6. Now, if you were to write it twice, I'm not going to necessarily take off, but I want you to realize that like on a test or DPM or anything like that or final, whatever you have to take, it will not repeat them. Okay? So let's look at this one. We have 0, 1, 0, 7. Did x repeat?
Yes.
Yes. So is it a function? No, it's a relation only because x repeated. So it's a set of ordered pairs. That's a relation. So it's still a relation, but the x repeated, therefore that's why it's not a function. So my domain is 0, 1, and then it goes 0 again. Well, I don't need to write that again, and I have 7. And then range, my y is -2, 5, 3, 7. So in numerical order, what would that be? Then what? Then what? Perfect. Now, if you don't like looking at them like that, could you write them in a table? Yeah, you can plug them in however you want or wherever you want. Plot the points, I don't mind. Okay, so now we're going to look at graphs. I'm going to make my points a little bolder. Okay, so these kind of graphs are discrete graphs. And the reason we remember that is because there's dots only. It's only plotted with points. I say dots because discrete dots makes it easier to remember. Okay? It's dots only. There you'll never have lines. If there's a line, it's not discrete. It's continuous. Okay? So knowing that your domain and your range is going to be listed inside fancy brackets, just like what we've been doing. Because if I don't connect these dots, well, can I say the point 0, 1? That's kind of between those two dots. Well, is there a point at 0, 1? No, so you can't say it. You see what I'm saying? The only points there are the 1, 2, 3, 4 that are there. So that's why you have to write it as a list. Okay, so do y'all remember how to decide if these are functions or not? The vertical line test. So with the vertical line test, that means if I were to draw a vertical line anywhere on this graph, it's never going to touch more than 1 point at a time. Did it ever touch more than 1 point at a time? No. So this is a function and relation. But look at this one. If I draw a line, did it ever touch more than once? Yes, right here, these 2 points, therefore it's a relation only. Does that make sense? Okay, I like finding them from graphs because I feel like it's easier. So your x-axis is what you're going to look at first because we're talking about domain. And if you start the farthest left, well, what point is the farthest to the left? At -4. And then the next one is at -2. The next one is at -1. And this one is at +1. So I'm just trying to figure out how far from 0 it is. Now range is my height. So I'm going to start lowest. What's my lowest point? -2, and then I have 2 points at 1, which is fine because we're only paying attention to x when we talk about domain function versus relation. Oh yes, -1. And then I have a +2. So again, we have -2, 2 at 1, and then 1 at 2. And I go lowest to highest, so -3, -1, 2, 3. Any questions with those? Okay, when you're done writing that down, flip to the back. Oh, man. Okay, so here we have graphs that have what? Lines. So we call these continuous. And I'm not going to test y'all by asking is it continuous or discrete, but I do expect y'all to have the domain and range correct, and that's where they differ. So continuous is lines and dots. Well, you don't always see dots, but anywhere on a solid line is considered a dot. You can put one anywhere. Technically, there's a bunch of dots so close together that they make up a line. Okay, because everything's a solution on that line. Okay, domain and range here, domain and range, are written in interval notation, which is what we just got done learning. Yes? Oh, my bad. Sorry, thank you. Okay, so again, we still do the vertical line test. If I drew a bunch of vertical lines, does it ever touch more than once? No, so function or relation? Okay, what about this one? Function. Here. function. What about here? Relation, because it touched twice. Y'all see that? And now let's look at domain and range. Okay, the best part about these is linear lines. Well, how far left is this going to go? Forever. How far right is it going to go? Forever. So what do you think your answer is for domain? Negative infinity to positive infinity. Okay, what's the lowest it goes? Negative infinity. What's the highest it goes? So it goes up, down, left, right, all of that forever. So therefore, it's all real numbers, negative infinity to positive infinity for both. Yes? Okay, what about this quadratic graph that's upside down, number 4? Well, domain is left to right. What's the farthest left this is going to go? Well, if we follow the pattern, is it going to keep going left forever? If we follow the pattern, is it going to keep going right forever? Yeah, quadratics they don't grow quickly outwards, but they do grow outwards. So this is negative infinity to infinity. Yes. So then with range, what's the lowest it goes? Negative infinity. And what's the highest it goes? 3. And it touches 3, so it gets a square bracket. The only time you'll use parentheses on graphs like these is when you have an infinity. When you have an asymptote. Do y'all remember asymptotes? They were usually on those graphs that look like ramps. Yes? Which we don't really deal with. Okay? Or not yet, at least. And then you'll also use them if you ever have an open dot. But see how both of these are closed dots? So we don't have to worry about it. Does that make sense? Okay. So look at this one. What's the farthest left it goes? These have stopping points, no arrows. Negative 3. And what's the farthest right it goes? What's the lowest it goes? And what's the highest it goes? Yep. Okay, and then the circle or oval. What's the farthest left the oval goes? Negative 3. What's the farthest right it goes? Positive 3. What's the lowest it goes? 2. And the highest it goes? There you go. We like those. They're not bad, right? Okay, the next 4 give you equations, but I'm going to graph them because without our calculator and visuals, they aren't the easiest, unless you want to memorize a bunch of stuff. Okay, so this first one, if I come to my calculator and type y equals x and I hit graph, it's a diagonal and it's a linear equation, which means it's going to go on forever. Well, what do you think that is, a function or a relation only? Function. And what do you think your domain and range are? You're exactly right. Negative infinity to infinity for both. Because it goes left forever, it goes right forever, it goes up forever, it goes down forever. Okay, so the next one. Pretty much any time it's a linear line, y'all, it's going to look like those 2x plus 1 graph. So it looks very, very similar, except it went up a little and it's tilted a little. So it's not much different. So same thing. Is it a function or a relation only? Function. And then doesn't it go left forever? Does it go right forever? Does it go up forever? Does it go down forever? Yeah. Okay, the next two are special cases, though. Do y'all remember learning Hoivux?
Yes.
Hoivux? Even if the words just sound a little familiar. That's a U in the middle, I promise. Okay, so I'm going to tell y'all what that means. We'll go into more detail when we get further into this unit, but today I'm just going to talk about it a little bit. So Hoi stands for horizontal, zero slope. It's a y equals equation. So you know it's a Hoi equation. See how there's no x? That's how we knew it was a special case. See how this one has an x and no y? That's how we knew it's a special case. So as soon as you see where it only has one letter, it's a special case. So knowing that, we have, well, the nice thing is the first one we can graph because it's a y equals. Well, y equals 5, so it looks like this. Well, does that go left forever? Does it go right forever? Is it a function or a relation only?
Function?
Because if I draw a vertical line, it never touches more than once. Okay, and it goes left forever, right forever. However, does it go up and down forever? What's the only height it has? 5. And it touches 5, so there's your range.
Oh, so we just box numbers. That's why you're putting brackets. Because it's 2 numbers. But for the brackets, it's only because it's a number.
The square brackets? Yeah. The only time you'll use a parentheses on a number, like I was saying earlier, is with an open dot or an asymptote. And you won't see lots of those. Okay, so Vux, we cannot type in the calculator because we cannot type an x equals equation in our calculator. But it's vertical and it equals -1. So x is -1 here and it's a vertical line. So this is a function and relation or a relation only? Relation only. Because if I draw a vertical line, won't it touch everywhere forever? Therefore, it touches more than once, right? So it's not a function. Now, domain. Where does it go side to side? It stays where? -1. It never moves side to side from -1. What about range? Does it go down forever? Does it go up forever? Yes. Those were our special cases. And like I said, we'll talk about Hoivux a lot throughout this whole unit. Okay, last three are we're going to go kind of quick and simple because it's literally labeled domain and range. So obviously we know the domain and range. Does that make sense? X and Y literally labeled for you. But I do want to talk about if they're function or relation. So is this a function or relation only? Function. Function or relation only?
Relation.
Function. X cannot repeat. Y can.
Oh, the other, so 3 is relation.
Is this a function or relation only?
Relation.
Why?
Because 7 repeats.
Because 7 has 2 arrows. Therefore, it's repeating. Did y'all see that? So, see how 7 has 2 arrows, one pointing to -3 and one pointing to +3? That means X repeated. Because that's the X. 7 is the X. And since it has 2 arrows, that means it was used twice. See how here every X only has 1 arrow? It's because they were each used once, and you can only use an X value once. X cannot repeat. So if you have 2 arrows coming out of an X value, then it's not a function because it repeated. Okay? Now the nice thing here is domain is literally just -2, 4, 5. It's listed for you. Range. And the nice thing about mapping is these two and these two kind is that they should be written in numerical order for you, which makes life really easy. And they shouldn't be repeated. Oh, that's not a -3, sorry. +3, 5, and 6. Now, the second one is a table. 1, 4, 6. Now, what would my range be, least to greatest?
-3 and common 4.
4. You're exactly right. Sometimes my braces start to look like 3s. Okay, and then the last one My x value is negative 427. And then negative 3, positive 3, 6, 8.